session that we are going to learn about the Boolean algebra and logic gates. Digital circuits are required in all important electronic devices such as mobile phones, calculators and computers. While we design these type of digital circuits in a digital computer, we need to have the concept of Boolean algebra, which is a branch of mathematics. And it has been fundamental in the development of digital electronics, and it is used in modern programming languages. A digital circuit works with the digital signals where all the values are discrete. A digital circuit is designed by using a number of logic gates on a single integrated circuit. And you could see the picture of a PCB, which is called a printed circuit board, which had been fabricated with some IC chips and along with the some circuits embedded onto it, so that which will be used for some functionality. And the third picture, which depicts some logical representation of the same PCB. The name Boolean algebra has been given in honor of an English mathematician, George Boole, who proposed the basic principles of Boolean algebra. So he actually started teaching at the age of 16, and even he started his own school at the age of 19. And by his mid-20s, he had mastered almost all the important mathematical principles. Based on the domain knowledge that he had, he proposed the basic principles of Boolean algebra. So every day that we have to make some logical decisions. Should I carry science book every day? Or this mathematical expression, is it correct or not? And is the Chennai is capital of India? So all these questions, while we answer these questions, so either it will just give you the answer as yes or no. That's a definite values. So the the results, either it could be true or false, and those values which are called truth values, and this could be represented by logical constant 1, or it could be 0, and 1 means it is true and 0 means it's false. And the variable which can store these truth values are called logical variables, or binary valued variables, or you can just say it's a Boolean variables. The digital circuits use only two states, as either on and off, or high or low, or true or false. And at the same time, the binary number system use only 2 bits, either 0 or 1. So therefore, it's very natural that the binary number system is used for the study and analysis of the digital circuits. In Boolean algebra, the basic logical operations are OR, AND, and NOT, which are symbolically represented by dot, plus, and bar over it, or either it could be a single apostrophe, respectively. So these symbols are also called as logical operators. These operations can be achieved with the logic gates such as OR, AND, and NOT gates. And logic gates form the fundamental building blocks for all the digital circuits or logic circuits. Gate is an electronic circuit with one or more inputs but only one output. And we'll just see each gate one by one. And the first gate is the OR gate, and OR gate performs logical addition, and it combines 2 or more input variables so that the output is true if at least one input is true. And if any signal goes high, the output signal will also go high. And if all the inputs are low, the output is also low. And here we can just say A and B are the input logical variables and C is the output, and the output C is given by the expression C is equal to A plus B. Let us observe the behavior of the basic logic gates. So we'll take up the OR gate. So in the OR gate we have A and B are the input variables and C will be the output variable. And when we give, so this is the symbol, and when we give the input as low in both the cases, you will get the output as low. And the basic principle is, even if you get one signal as high, you will get the high output. So in these both two cases, you will get the high output. And if you have the A and B as a high at the same time, you will have the high output. So we will just see with the AND gate, and AND gate performs logical multiplication. The AND operator combines two or more input variables so that the output is true only if all the inputs are true. Or we can just say, in other words, if any input goes low, the output signal will also goes low. And with the A and B or the input logical variable, the output C is given by the expression C is equal to A ANDed with B. So we will just see how the AND gate performs. We have the symbol represented like this, and we have two variables A and B, and we have the C, that is A and B. And so here even if we have one input is low, the output will also low. And if and only if both the inputs are high, you will get the high output. So we will just see A and B is equal to 0, and that is equal to 0 low. And so in all the three cases, since we have 1 0 as an input, naturally the output is also low. And in both the cases we have 1, and we will get the 1. So we'll just see with the NOT gate, which is an inverter. So it functions as if it inverts the input. So NOT gate inverts the input. It has one input and one output. And if the input is low, the output is high. If the input is high and the output is low. And the input is marked as A, and the output is marked as A bar. And the output A can be read as complement of A. So from this slide, we can just observe the functionality of NOT gate. So when we give the low signal, the output signal is high. When we give the high signal, the output is going to be low. So far we have seen with the basic logic gates, which are OR and NOT. And the other members, the other basic gates are also NAND, NOR and exclusive OR. And these are also the basic building blocks in order to design the digital systems. Whenever you just want to have construct the digital systems, we can make use of these building blocks, and we can see with the NOR gate, which is a circuit with an OR gate followed by an inverter. And as far as this gate is concerned, its output is true if both the inputs are false, otherwise the output is false. Or we can just say, if you want to get one as an output, both the inputs should be 0. So here from the picture that very well we can just construct the NOR gate by OR and NOR, or has to be followed by NOT gate. So this is the logic circuit for the NOR gate. This is the logic symbol of NOR gate combined with the OR and NOT. And from the truth table that we could observe that if both the inputs are low only, you will get the high output. In all the other cases, you will get the low output only. The NAND gate operates an AND gate followed by a NOT gate, and it acts in the manner of the logical operation and followed by inversion. So as we fabricated this NAND gate, the output is false if both the inputs are true. Otherwise, the output is true. Yeah, all, or we can just, in other words, we can just say the output of the NAND gate is 0, and if and only if both the inputs are 1. Otherwise, the output is 1. And we can just have the logic circuit of this NAND gate. So AND gate followed by an NOT gate. So this is the logic symbol of NAND gate. It's an AND followed by a NOT gate. So from the truth table that we can simply identify that both the inputs are 1, you can have 0. In all the other cases, it will be output as 1. So these are all the logic symbol and the truth table for exclusive OR and exclusive NOR gate. So we have studied almost all the basic gates, and we can start building some elementary digital circuits. So we'll just take up a sample as y is equal to a and with b, and that could be odd with the c. So that is a and b plus c. So we have taken up the expression as y is equal to a ANDed with b, and that could be odd with c. And so we will just design a basic circuit. So it's a digital circuit where we are just going to form a AND gate and an OR gate to get this particular expression. So we will just observe this digital circuit, how it behaves. So all the theorems of the Boolean algebra is listed out in this page. Thank you.